Okay, so say I want to find the intervals where this function is increasing and decreasing. Okay, so I'm going to have to get a sign diagram of the derivative. Now, finding the derivative for this function, I'm going to have to use the quotient rule because it's a function over another function, isn't it? Okay, so the quotient rule says get the derivative of the numerator. So the derivative of the numerator there is 3, multiply it by the denominator. Okay, and then subtract the derivative of the denominator, which is 2x. Take 1 multiplied by the numerator. And then divide it all by the denominator squared. Okay, that's the quotient rule. So that's the derivative. Now let's see if we can clean this up a bit. Okay, so what I'll do is I'll expand these brackets here. It gets me 3x squared negative 3x. Take 6. Let's use FOIL on these. Okay, so it's going to be subtract 6x squared negative 18x negative 3x, which is negative 21x, and plus 9. Okay, and that is all over. Now see here I've got a quadratic. Let's write it in factored form. So factors, I'd get the factors of negative 2 that add to negative 1. That is negative 2 and positive 1. So I can write it like this, can't I? I can go, well, that is really the same. That all squared is the same as x take 2 squared, x plus 1 squared. So I'm just factorising the quadratic there. Squaring them both. Alright. So let's continue to clean this up. Let's collect up like terms. So that's going to give me 3x, that's going to give me negative 3x squared plus 18x, take 15. That is all over x take 2 all squared, x plus 1 all squared. Alright. Now the numerator here, I can see that I can take out negative 3 as a common factor, so I'll take out negative 3 as a common factor, and that will leave me with, because I don't want a negative x squared term, do I? Alright, I won't be able to factorise it then. So I take out negative 3, that leaves me with x squared take 6x plus 5 on the inside. And that is all over x take 2 all squared, x take x plus 1 all squared. Now what I'm going to do is I'm going to factorise this quadratic here. Factors of 5 that add to negative 6, and that would be negative 5, negative 1. So I'm going to have negative 3 x take 5 times x take 1. That is all going to be over x take 2 all squared, x take x plus 1 all squared. I keep saying take there. Okay, so that's the derivative in a much nicer form. Now, from this I can get the critical values for my sign diagram, can't I? So, if I'm going to draw my sign diagram, okay, I can see that if I make x2 here, it's going to be 2 take 2, which turns this into a 0, which turns the denominator into 0, which makes it undefined. So I know that 2, let's put 2 here, is going to be an asymptote. Alright? If I make x negative 1 here, negative 1 plus 1 turns this bracket into a 0, turns the denominator into 0, makes the function undefined, so therefore I know negative 1 is also going to be an asymptote. Okay? Alright. The numerator of the critical values here, the critical value is 5, because 5 take 5 turns this bracket into 0, turns the whole lot into 0, so 5 is a critical value, and 1 take 1 would turn that into a 0, so 1 is another critical value. Okay? Alright. So, there's my two asymptotes, there's my other critical values. Now I just need to sub different values in to see what happens in between. So if I subbed in negative 2 here, I sub in negative 2, figure it out, and that's going to give me a negative answer. Okay? Between negative 1 and 1, I'd sub in 0. If I sub in 0, you can see it gives me another negative answer. Remember, I'm subbing back into the derivative all the time, not into the original function, to the derivative. If I subbed in, say, a half between 1 and 2, I get a positive answer. If I sub in 3, which is between 2 and 5, I get a positive answer. If I sub in a number greater than 5, I get a negative answer. So there is my sign diagram. Okay. What this tells me is this. It tells me the function is decreasing at less than negative 1. It is decreasing and then increasing there, okay? And then it's increasing and then decreasing there. Okay, so what I can say is this. I can say f of x is decreasing, so there's the intervals for x less than 1. So from here, you can see it's decreasing there and decreasing there. Okay, and decreasing at greater than 5. So less than or equal to 1, and x greater than or equal to 5, and it's increasing. Or you can see that it's increasing here and here where the two positives are, so between 1 and 5. So x greater than or equal to 1 and less than or equal to 5. Okay, so they're the intervals in which it's decreasing and increasing.